Welcome back. In the previous lesson, we learned how to get the limit definition of derivative intuitively using the point-slope formula. Well, today we're going to go into a little bit more detail in understanding what that limit actually means in relationship to the slope and the definition of derivatives using some examples. Well, let's get started.
In the previous video, we showed that the limit definition of derivative is the limit of f of x plus h minus f of x all over h as h approaches 0. Well, today we're going to go into a little bit more depth about this section right here, the limit as h approaches 0. Well, I'm going to use the function f of x equals ln of x. And I would like to find the derivative, or f prime of x, at 1. Well, I know that the derivative of this function at 1 equals 1. This h represents the distance between the value that we actually want to calculate and some number that's close to it. So for this first example, I'm going to start with h as 0.3. So if I plug in that into this function, we have f of 1 plus 0.3 minus f of 1 all over 0.3. Now, this means ln of 1.3 minus ln of 1 all over 0.3. And this value equals 0.87. Now we know that the derivative at 1 should be 1. So this is off. So we're going to use a number that's a little bit closer. H equals 0.2. So ln of 1 plus 0.2 minus ln of 1 all over 0.2 equals 0.91. Now let's get even closer. So I'm gonna let h equal 0.01 and let's solve for that. Ln of 1.01 minus ln of 1 all over 0.01 equals 0.99. And this is approximately equal to the derivative of 1 that we actually need. So what we're doing is the limit as h approaches 0. If you look at what we did, we started with h equals 0.3. We got a little bit closer for h equals 0.2 and a little bit closer at h equals 0.01. The goal is to make h so small that it's 0. Now, graphically, what exactly does that mean? Let's say we have our function ln. So this line, this slope, let's say this slope represents the derivative at this point. If this is 1, and let's say this is exaggerated, but let's say here is our 1.3. This would be the slope, and you see how that's off, where h equals 0.3. Let's get a little bit closer here. This is 1.2, where h equals 0.2, and this is the slope. Let's go to 1.1, where the slope 1.1, where h equals 0.1, and you see by this point we've gotten really close to the slope that we want. So by the time we make our point 1.001, we're almost exactly on the line of the slope. So that is what we're doing when we take the limit as h approaches 0. We're saying, what is the slope as we shrink the distance between the 2 points to where the 2 points are basically on top of each other.